My goal is to do 4 problems from 2000 or from the problem set F. And whenever I don't finish, I'll assign for homework and we can talk about them in class. All right, so 2007 number 2. This one, please make sure you read the function or read the problem entirely. So A, how many gallons of water enter the tank during the time interval from 0 to 7? Round to the nearest gallon. All right, so the rate at which water enters the tank is given by the function f. So we integrate this function from 0 to 7, and using your calculator, verify that that would be your answer. B, for the time interval between 0 and 7, find the intervals during which the amount of water in the tank is decreasing. Amount of water in the tank is decreasing. Okay, so we're given 2 rates. We're given the rate at which water goes into the tank and the rate at which the water is coming out of the tank. So the water in the tank would be decreasing when G of t is bigger than F of t. So what does this mean in words? More water is going out than is coming in. So the amount of water would be decreasing. So we find when G of t equals F of t, and this is done for us. We're told that they intersect at these points. Now you can verify in your calculator as well. That these would be the points of intersection, but you don't have to do that because it's already given to us. Okay, now look at graphically. G of t is the piecewise function. So notice that at 1.6, G is above the function f. So the amount coming out of the tank is on top of, it's bigger than the amount of water entering the tank. And then at 5.07, again, notice here, out is over, it's more than, it's on top of the graph of f. So we can verify where that those point of intersections are the answer as well. Alright, so now between 0 and 7, at what time is the amount of water in the tank greatest? To the nearest gallon, compute the amount of water at this time. Okay, so amount of water in the tank the greatest. We're looking for an absolute max here. Where do absolute extrema occur? So they occur at critical numbers and endpoints. So we know that we'll have to look at 0 and 7. And now we want to know if it's a maximum, where does the derivative, where does the rate change from positive to negative? So we have these 2 values. We know that the functions intersect at 1.617 and 5.076. But we said at these points, the function, the rate of change would switch from negative to positive because G, the water leaving the tank, is more than the water in the tank. So these critical numbers, the points of intersection here, wouldn't be where the absolute maximum occur. They would be minimums because the function would be switching from decreasing to increasing. So what's the only other critical number? At x is equal to 3. Alright, and x is equal to 3 is where the derivative doesn't exist. But at x is equal to 3, so before 3, the rate at which water goes into the tank is more than it's coming out, and then from 3 to, well, 5.076, it switches. So the rates switch from positive to negative. Okay, so now we're discussing the amount of water in the tank. These are the rates at which the water enters the tank and leaves the tank. So the amount of water in the tank, we're going to have to integrate. And what are we going to integrate? We're going to integrate the rate at which the water goes into the tank minus the rate at which the water comes out of the tank. It asks us when it occurs and what it is. So 0, 3, and 7. At 0 hours, we're told that the amount of water in the tank is 5,000 gallons. At 3 hours, we take that initial condition and we integrate between 0 to 3 the function that represents the total amount of water in the tank. And again, use your calculators, verify that you get 5,127 gallons of water in the tank. At time t is equal to 7, you take the amount of water in the tank and add to that the integral from 3 to 7. Again, how much is coming in minus what's going out of the tank. So then, our conclusion, the amount of water in the tank is greatest when t is equal to 3 hours. And then it says to the nearest gallon, compute the amount of water. And the amount of water in the tank is 5,127 gallons. So use the words of the question to write your justification. All right. Next question from 2008, number 3. Oils leaking from a pipeline on the surface of a lake forms an oil slick. Volume increases, so the rate of change of the volume, it increases at a rate of 2,000 cubic centimeters per minute. Now, I've said this in class before, use your units to guide your answers, and that will be helpful for you. So we're given the rate of change at the instant when these conditions are satisfied. So for part A, radius is 100, height is 0.5, and the radius is increasing at that rate. What's the rate of change of the height of the oil slick with respect to time? So we're given our volume formula. So this is a related rate problem. We have to derive this function with respect to time. So we need both implicit and product rule here. First times the derivative of the second plus second times the derivative of the first. We're solving for the rate of change of the height, so now we have all the information we need, and we're going to plug that in. 100 squared times our unknown. All of these problems are calculators, so please don't try and do any type of simplifying by hand. It doesn't, so in centimeters per minute, what would the rate of change of the height be? So verify that you can get that answer. A recovery device arrives on the scene and begins removing oil. Rate at which the oil is removed. Is this function? Oil continues to leak, so we still have oil leaking at this given rate. So 2,000 cubic centimeters per minute. And this rate is in cubic centimeters per minute as well. Find the time when the oil slick reaches its maximum volume. Okay, so we're finding an absolute max here. Where do absolute extrema occur? Endpoints and critical numbers. So where's the critical number? The critical number is where the derivative, the rate of change, would equal 0 or not exist. So look at what we have here. The rate of change of the volume, it's the oil that's leaking out minus the oil that they're able to recover or remove. Okay, so this is what I'm losing, and I'm going to take away from that what the device is removing. So where would this equal 0? Get square root of t is 5, so t is equal to 25. Now what are the endpoints on this? Well, look at the domain of this function. So I have my rate here. I know that I can't have a value of time less than 0. So when I plug in a value between 0 and 5 into this function, 2000 minus 400 root t, I get a positive value, negative value after 25. So the oil slick, use the words of the question to write your justification, reaches its maximum volume at t is equal to 25, and what's our unit of time here? Minutes. And y, since the rate of change of the volume switches from positive to negative. And lastly, by the time the recovery device began removing oil, 60,000 cubic centimeters of oil had already leaked, right? But do not evaluate an expression involving an integral that gives the volume of the oil at the time found in part B. Okay, so look at our units here. We already lost 60,000 cubic centimeters of oil. Now what would be the total volume of the oil at 25 minutes? And this is the oil that has spilled into or from the pipeline. So 0 to 25. And then what's the rate of change of the volume that we talked about? It leaks out at a rate of 2,000 cubic centimeters per minute. And we're taking away from that how much we're able to recover. And it doesn't ask for you to evaluate it, so that would be our final answer. And I'm going to stop the video so I don't run out of time, and I'm going to post another video. I'll do with you the 2010 questions.